All right, hello HashiConf. My name is Paul Hinze. I'm here to talk to you about the Terraform roadmap, representing all of the work that the many people it takes to make Terraform do its thing have been up to for this past year and where we're headed. So this talk is divided into 4 different sections. We're going to talk about some of the exciting stuff that we have shipped. We're going to be talking about some of the things we're going to be doing and where we're headed on that front. And then we'll take a step back and put it all in context with a little bit of product philosophy. And then we'll also have a section where we're talking about Terraform and the ways in which it works with the other HashiCorp products. So let's dig in. I'm going to start with a little bit of context setting. I've got this working definition for infrastructure as code. And the idea here is it's a strategy for capturing complexity. So infrastructure provisioning is something that produces a lot of complexity. And when you have a lot of complexity, this notion of an as code strategy is how do we capture this complexity into code? And then what that allows us to do is borrow tools and practices from software development in the way that we handle this complexity. So what I like about this definition is it kind of works for any as code kind of term. So you can flop out infrastructure provisioning there for policy enforcement, for instance, and you can get policy as code, same structure. So that's what we're doing with Terraform. And so let's kind of work our way into the problem space here. So we started with an open source CLI tool as a lot of our, basically all of our products started. And we introduced a new workflow to the world, which was a consistent workflow over a bunch of different cloud provisioning stories. And this workflow was brand new. This idea of Terraform plan was a brand new idea of we can predict what's going to happen before it does to make sure it looks right before you do something. And so this workflow ended up looking something like this. You're running Terraform plan, you're writing some infrastructure as code, you're running Terraform plan, and then apply, and then you're probably storing the resulting code in your VCS system. And so this is a good example of that infrastructure as code strategy of, hey, what are you going to be doing with your software code? You're probably going to be checking it into a VCS system. Same story here. You're going to check your infrastructure code into a VCS system. And so this flow works really nicely for a single person or maybe a really tiny team where you're just running these commands on your laptop and you're checking the resulting code into a version control system. But once your team starts to grow, there's this really common pattern where the Terraform apply operation starts to be kind of a friction point of coordination for a team, where the question of who's running Terraform apply from what laptop and are we sharing credentials and we don't want to step on each other's toes causes you to want to take that Terraform apply operation and move it into a third-party location that's triggered based on your VCS system. So this presents a question that every Terraform team needs to answer, which is who drives that Terraform truck? Who is going to run Terraform apply for us? Now, this is open source, so the DIY route is always right there for you. You can grab your generic CI/CD platform. Maybe you're going to get help from a certain butler, maybe a mustachioed construction worker. Any of those technologies works to be able to solve this problem for you. But this is where we step in with our platforms for Terraform collaboration, Terraform Cloud and Terraform Enterprise. We started with this key problem of collaboration on Terraform, and we've solved that in these platforms, and we want those to be the best place to collaborate on Terraform. But then what we've been doing is basically stacking as much value as possible into these things, month on month, quarter on quarter, year on year. And so these are the platforms I'm going to be talking about, a lot of the enhancements that we have. And again, Terraform Cloud is the SaaS platform. So that's there with a free tier that's ready for you from day one. And it's there to scale with you to as big as your business gets as a SaaS platform. And then Terraform Enterprise takes that same software and packages it up into a self-hostable unit. So for people that really need to be able to self-host this same story, that's there for them as well. But at the end of the day, what we're trying to do here is just tell a singular Terraform story. And yes, it's a story that has many parts to it, but overall, our goal is to be holistic and for it to all feel like it fits together into a singular Terraform story. So that's the context. Now let's talk about some of the cool stuff that we've shipped. So to start, let's look at the Workspace Overview. Now, this has actually showed up in a couple of different venues, but I needed to talk about it because it just represents this culmination of things that we've wanted to do for a long time. And it's this idea of taking the full advantage of the web platform to be able to present information to the user. So the CLI is very cool for a lot of things, but information density and sort of interactive information presentation is not its strong suit. And that's where the web really shines. So we've taken that philosophy and applied it to this page that's one of the most common pages in Terraform Cloud and Enterprise, the workspace, the first page you see when you look at a workspace. And now what you have here is the resources under management are right there, the outputs are right there. Really critically, for me at least, the README rendering. So we're pulling in the README from the repo and rendering it right here. So for me, a lot of these features together and a lot more make this like the home page for a given piece of infrastructure. The first place that you might want to grab the context about what this piece of infrastructure is up to. And then you can kind of hop to the repo or the more recent runs, wherever you want to go. And so we're really excited about the place that we've gotten this page. Yes, it'll even continue to get even better from here, but we've made a lot of progress recently, and I think it's pretty cool. We've taken that same strategy for the Terraform plan and apply operations. And so what does a full fidelity web experience look like for these things? And the idea here is like a Terraform plan and a Terraform apply are pretty information dense operations. There's a lot happening, and traditionally that's just presented as scrolling text. And yes, on the CLI, we've done some things to like produce a little bit more of a concise output. But in the web browser, we have so much more capability to give you animations that give a sense of progress, as well as pulling up the most relevant information while still allowing you to drill down interactively. So this is really cool. And I think it's most valuable when it comes to error conditions. So when you think about it, and anybody who has worked with either infrastructure as code or with software will tell you, you actually spend most of your time reading error messages. Because when you're in the development mode, what you're doing is you're writing code and then you're running it and you're seeing some sort of an error, and then you're trying to loop and fix the error until it is green. Once it's green, you put it away. And so if you put all that together, you actually spend most of your time looking at errors. And so that's one of the things that causes us to spend a lot of time on error messages in Terraform. The CLI has had a lot of work to produce useful error messages. But again, within the web context, we can do a lot more to pull up the most relevant information. So you're saving those little bits of time in terms of scanning and finding the error message, knowing what to do next. Those are the kind of tiny productivity gains that like multiply over hundreds and thousands of times over the course of time in general, and they really make a big difference. So it's worth us spending time on this, and I'm excited that we've made these strides that we have. Another thing that we've gotten in that's just a nice thing to have is Workspace Tags. So once you have a good number of workspaces, you're going to want to apply some kind of taxonomy to it. And tags are a really flexible way of doing that for your your filtering and sort of slicing and dicing the workspaces in different ways. So I'm glad we got that in place. On the agents front, so if you're not familiar with Terraform Cloud agents, these are very cool. They're little binaries that you can run in a location of your choosing, and that binary will reach out to Terraform Cloud, and now Terraform Enterprise as well, to ask it for all the context it needs to be able to execute the Terraform operation in that location. And so what this does is it opens up a whole host of new use cases where you've got, especially for on-prem infrastructure, where you've got infrastructure that you want the Terraform workflow to apply to, but you don't want to hold it, you don't want to have it listening out on the open internet. So you host the Terraform Cloud agent close to the infrastructure, it reaches outwards to the Terraform collaboration platform, and then it does its thing from there. So now that these things are working in Terraform Enterprise, you've got this whole suite of solutions. You can adopt the SaaS, have everything run from the SaaS. You can adopt the SaaS, use these agents via the SaaS. But then if you're running Terraform Enterprise, you can control the location of both the collaboration platform and the Terraform execution. So we can support a bunch of different network topologies now and a bunch of different cool use cases. So let's pivot a little bit over to the provider ecosystem. It's been just amazing to watch the Terraform provider ecosystem flourish over the course of its life. And the world we're in now is one where you've got a set of logos here from one of our recent updates, but we've got these companies that are just recognizing that infrastructure as code as a segment is a competitive advantage, that it's a part of the market they want to be able to address. They want infrastructure as code users to be able to interact with their service. And they're coming to us and saying, hey, we want a verified provider that's in the registry, and so that Terraform works with our service in an official capacity. And so that's just really cool that companies are recognizing this, that the industry is recognizing that infrastructure as code is a worthwhile way of managing complexity in infrastructure provisioning, and it's been very cool to watch the ecosystem flourish here. So verified providers always growing, community providers, of which there are hundreds or thousands now, growing even more quickly, and then official providers are the ones that we write within HashiCorp and maintain. So there are a couple of updates on the official providers I want to walk you through. The first one is Google Workspace Provider. So this is a kind of a simple story that has a lot of implications. So one of the things that we've had this thesis about recently is the idea that the identity platform world is a set of provisioning tasks that would really be able to benefit a lot from the infrastructure as code, from the Terraform workflow. So we put out the Azure Active Directory provider, and this Google Workspace provider is one we put out recently. And it's pretty straightforward if you look at it. It's the ability to provision groups and users, and then put users into groups. But this is an area of a lot of complexity in organizations, and we think the infrastructure as code workflow could do a lot for this. So we're really excited to see what the community does with this provider and whether or not it's useful. Over on the Kubernetes front, so we've hit a huge milestone with the Kubernetes manifest resource landing as a beta resource in the official Terraform Kubernetes provider. This was a story. This took us some time to implement. I'll tell you why. So the SDK that we use to build Terraform providers, it had some assumptions in it about the APIs that it addressed. And the assumptions were basically, given an API endpoint, the requests and response are going to have a certain structure to them that we can use to sort of build out the Terraform provider. In the case of CRDs in Kubernetes, you have one endpoint or a set of endpoints that's incredibly dynamic, where the requests and responses are changing really drastically. And so we ran into this wall of trying to implement the CRD support within the Terraform provider. So this was an important enough workflow for us that we ended up peeling away and basically taking on the task of building a new version of our SDK that allowed for this kind of flexibility so that we could meet this use case. And we've made it to the other side. This functionality now works. And so you can now work the full life cycle of a Kubernetes cluster, from launching the underlying infrastructure to configuring it to managing CRDs. And so this is a cool story, and I highly recommend Phil's talk. He's the head of the product group in this for our providers, and he knows everything about Kubernetes plus Terraform. So check out his talk to learn more about that. Great. So that is a whole host of things that we've been up to lately. Now let's pivot and talk about some of the directions we're headed in. I'm going to actually zero in on one specific direction I want to spend some time on. So in order to set the stage for this, I want to talk about one of my favorite of our principles, this idea of workflows over technologies. One of the reasons I like it is because there's kind of an inherent tension built into it, which is we are a technology company. So at the end of the day, we're shipping bits. We're making technology. And so, but here we are saying, wait, workflows are more important than technology. There's a thing that we're actually attempting to achieve with our technology, which is to facilitate workflows. And so this kind of introduces a sense of like intentional doubt into everything that we do, all of the solutions that we produce, and all of the things that we design. And so keeping this in mind has been really critical to our success, I think. And so with that in mind, I want to talk to you about one specific technology, and that's the HashiCorp configuration language. So HCL is the language that you use to configure all of our products, but it's really front and center in Terraform because you're using the language to write your infrastructure as code. So that is the language that you use to express infrastructure as code, and it was really designed with that in mind. We had a couple of design goals here. We knew we wanted it to be declarative. We knew we wanted it to be both human and machine friendly. So more so than like your JSON is something that's like designed to be machine friendly mostly. And we wanted something that was like designed to be read and written by humans, but also parsable by machines, as well as something that has a JSON interoperability layer that I'll get to in a second. But really critically, we wanted to balance constraint and complexity. And what I mean by this is we knew that we wanted to we wanted to be able to users to be able to express a lot of really complicated infrastructure configurations. We wanted to pack in enough features to allow to do that elegantly. However, we also wanted to avoid adding so many features that any given Terraform configuration could really explode in complexity. So there was a lot of very tactical, strategic omissions from the language in order to keep it relatively small and keep the sum total of complexity possible in a Terraform configuration relatively limited. And then that JSON compatibility layer was there as an escape hatch. So you can generate the JSON that you need if you want to do something more fancy. But for most users, we believed, and we still believe, that HCL strikes this balance really well. And so putting it into this workflows over technologies concept, you've got HCL as a technology that gets you access to the Terraform workflow. And what we keep running across as we work with users is various users for whom the HCL adoption is a barrier. The ability to adopt that technology is hard for them for various reasons, and that prevents them from getting access to this workflow. And yes, we have that escape hatch of the JSON compatibility layer, but that's a really high bar for a lot of people. There are two kinds of teams I want to highlight here that really have gotten us thinking about this problem. One, you have the centralized team that maybe are writing HCL themselves, but they're also responsible for evangelizing and getting a larger organization to adopt Terraform workflows. And so they're going team to team, sometimes dozens, maybe hundreds of teams even, and saying, hey, we want you to adopt this workflow. And they're running into various teams at the leaves of their organization saying, hey, this is a big deal. I don't really want to have to learn a new language in order to adopt this workflow. So that's one use case that we do see and really resonates with us. The other one is the interesting story of things like serverless and other workflows that really stitch together the idea of infrastructure and application in ways that blur the line between them. So if you think about, for instance, like an API gateway that triggers a Lambda that might be written in Python, that then writes a file to an S3 bucket, which triggers an SQS event, which triggers another Lambda that's, let's say it's also Python. You have all of this infrastructure that's right there in the central loop of your application, and the idea of like where is the application live? Is the application the infrastructure? Like the line is not as clear, and when that happens, teams that are managing applications like this really don't want to separate out the concept of their infrastructure code from their application code. They really want them to be very close together, and that makes a lot of sense to us. So we've been working on something I want to tell you about. CDK for Terraform. This is the cloud development kit for Terraform. If you've been paying attention to our blog, you've seen us make some pretty quick progress on this. So the cloud development kit is something out of Amazon that they've been working on for, and we've been working with them to bring this workflow to Terraform. And the whole idea is let's open up the ability for other languages to apply to infrastructure as code. So we're actually using some of the libraries produced by Amazon CDK, but CDK for Terraform is a HashiCorp project. It's an official HashiCorp project, and I'm really excited to tell you about it. So what it does is that basically we're taking over the JSON compatibility layer. And so all you need to do is write a bunch of different languages of your choice. We give you this tool called CDKTF, and that takes care of the translation. That's the on-ramp to the Terraform workflow. And so this is the idea that infrastructure as code can really feel, for these teams that for which this matters, it can feel a lot more like writing software. And so I'll show you what that means, just with a little bit of an example. Here's a file full of Python code, and this is infrastructure as code. And this is just super exciting just on the surface. So you can mostly ignore the top and the bottom here, because these are actually generated by CDKTF init. So this is boilerplate that's generated for you. It's really those three lines in the middle that represent the equivalent of what you'd write in an HCL file. I'm instantiating a random provider, I'm making a pet for myself, a wonderful pet, and I'm making the name of that pet the output. So my pet's name is my Terraform output. And so it's relatively straightforward, and this is using Python in order to get access to the Terraform workflow. And once you run it, it works just like any other Terraform code. The state gets stored in Terraform Cloud, and it turns out I got an eager Pika, which I didn't know about before this, and I looked them up, and they're very cute. And here's an eager one. So it all works, and it was done with Python. And again, there are more languages. There are 5 languages we support today, and that's going to continue to grow, and that's just very cool. So that's I'd really love to be able to deep dive further on this from here, but instead I'm going to reference a bunch of other resources that you can do to figure this out for yourself. So thing one, go check out Charles's talk. Charles from ShopStyle is going to be giving a more in-depth tutorial about getting started with CDK for Terraform. And then the other resource is the Pocket team. So Mozilla Pocket team has gone all in on CDKTF for their infrastructure, and they've been just great to work with because they work out in the open. Now, as you can imagine, for HashiCorp, I'm very fond of other teams that are working out in the open. So you can actually go and see their infrastructure code in CDKTF that actually runs their infrastructure. It's very cool. They actually did a office hours with us last month, and they're going to do another one soon. So keep your eyes peeled to hear it more from the Pocket team and learn more from them as they adopt CDKTF. Let's put this in a little bit of context. What are we doing here with CDKTF, and how does it fit in with everything else in the Terraform world? One of the ways I like to think about it is as a mirror. So Terraform has a workflow that it makes consistent over a bunch of different technologies, of the different clouds and the different providers that you can have in Terraform. You can flip that on its head and say, we want that same story of a workflow being more important than the technologies. So we're opening up, there are now more technologies that enable you to have access to the Terraform workflow. So it's basically us applying the same principle that Terraform was invented for to Terraform itself. So we think it's very cool, the sort of symmetry here. And there's more symmetry too in the problems that we're attempting to solve at scale in Terraform Cloud and Terraform Enterprise. We're trying to say, what are the consistent workflows that we see as users scale with Terraform in larger organizations? And how can we apply just enough technology to be able to support those users in their scaling, in their collaboration? And so the places that we do this innovation fall across these three categories. The open source core, which is the beating heart of Terraform, and it always will be. It always will be there for people to stitch things together themselves. Terraform Cloud, where we're providing a platform that we want to be the best way to collaborate and scale with Terraform, with a very generous free tier that's designed for small teams. It's designed to be like an obvious choice for a small team to just grab and not have to pay any money, but to just get some of these solutions for free. And then it scales with you from that day zero all the way up through to supporting some of the largest businesses in the world. And then the self-hosted option is there as well. So for people in environments where that's important, Terraform Enterprise is there to bring that same platform to you. Cool, now let's talk about Terraform and some of the other HashiCorp products. It's very easy to tell the story here because Terraform loves every other HashiCorp product because it has providers for every other HashiCorp product. We're an ecosystem tool by default. And so what's your integration with these other tools? Oh, well, it's right there. It's right out front. Check out the registry. You can find providers for Terraform plus other HashiCorp tool. And so this is cool because you can actually manage the whole lifecycle of these tools, the underlying infrastructure, as well as configuring, say, your Vault cluster or your Consul cluster. Also, you could not have to launch underlying infrastructure at all, just go straight to HashiCorp Cloud Platform and launch them directly. So great stories that can be told with Terraform plus every other tool. There's one story that I want to highlight here that we've been working on recently. It's very cool. Consul Terraform Sync is a special use case for network infrastructure automation. Now, it basically connects like a reactive loop between the Consul service catalog and a set of Terraform code using one of our many providers that can address a piece of network infrastructure. So say an on-prem load balancer, let's say. And the ability to say, hey, when this service catalog changes, a new node shows up, a new service shows up, I want to trigger a run of Terraform to reconfigure the network infrastructure. Super cool, and it's a really awesome tool that showed up within the last year, and you can learn more about it at a HashiConf talk. Melissa and Kim are going to walk through this. They're some of the engineers that built it, and they're going to talk about all of the use cases this opens up. It's very cool. Great, so we've covered a lot today, and I want to close by talking about what I want you to focus on, the things I want you to do going away from this talk. Thing one, use Terraform Cloud. That free tier is there. That's just designed to be so easy for you to pick up. So if you haven't picked it up yet, please do check it out and check out all of the cool stuff that I've talked about has landed in the platform recently. Number two, check out CDK for Terraform. This is a new product offering for us, and we're excited to bring it alongside of the other ways of using Terraform and really make it just as official of an option for using Terraform as any other way. And then third, I've referenced 3 other HashiConf talks in this talk that you might want to go look at. You should go watch every Terraform talk, and then maybe a couple talks for the other products as well. So I hope this has been useful for you, and I hope you have a great time at HashiConf. Thank you so much.